Hi everyone, so today we are going to graph exponential functions and find key characteristics from the graph. Get ready to unlock the power of math together. Let's dive right in. So we're going to go ahead and complete our table, graph the exponential function, and then look at the key characteristics of the graph. So let's go ahead and plug this in our calculator. So in order to graph this, we're going to click on y equals. We're going to type in our function 2 to the power of x. So remember the caret button or the exponent button is going to be above the division symbol. And then we're going to click on graph. And then in order to find our table, we're going to press second graph and we're going to find our table. So we've got some values here from -3, and then we've got going up to our +3. So we've got 0.125, you've got 0.25, 0.5, 1, 2, 4, and 8. So do the best that you can, especially with the decimal. So we know that's a little bit tougher for you, but do the best that you can. But at least for sure, we can plot in our whole numbers. And then for our decimals, just kind of approximate in between. So our graph's going to get very, very close to that y value of 0, but it doesn't actually ever cross. And the reason being is that you actually have an asymptote. Now remember, the parent functions for exponential functions always have an asymptote starting at y equals 0. So that's our asymptote here. When we figure out domain and range, we're looking again at our graph. So domain, so all possibilities of x's is all real numbers, or -infinity to +infinity. Our range is going to be the smallest y value, which is 0, going all the way up towards +infinity. Now the 0 does have a parenthesis, not a bracket, because again you have an asymptote there, so it does get very close to 0 but doesn't equal. Because our graph does not cross our x-axis, there is no x-intercept, and our y-intercept is at 0, 1. Now when we look at our graph, we are looking and seeing whether we are increasing or decreasing. So we are increasing on the interval from -infinity to +infinity. So what that means is that from left to right, we're going up and increasing. So when we're looking at end behavior, remember as x approaches -infinity, that's the left-hand side of my graph. So I'm going to be looking over here. So my function, or my y values, are approaching 0. And then when I look at x approaching +infinity, that's the right-hand side of my graph. So what is my function doing there? Those point towards the positive y values. There you have your characteristics of your exponential functions. So as part of our summary, our domain, right, all real numbers, whether you have growth or decay. Your range is going to be based off of your vertical shifts, if you have any, right? So that's important that you look at your range and also look at the graph in order to figure out what that would be. Your horizontal asymptotes, right? Your horizontal asymptotes always going to be written as an equation, but they're also affected by any vertical shifts up or down. So you do have to keep that in mind. There are 3 ways that you can graph. So you could use transformations. You can make a table of values, right, to get some points, or you can use your graphing calculator. So in this question, let's go ahead and plug this into our calculator. So we're going to go into y equals. I'm going to type in 2.5. We're going to raise to the x -3. And then the -5 goes outside of the exponent, so it just goes a little lower. We are going to graph. Okay, so in this case, what happens is that because we had a shift down, our asymptote is going to get affected. So we are going to shift our horizontal asymptote down to that vertical shift, which was -5. We will have an x-intercept now because it does cross. And our y-intercept you can find from our table. So let's get the x-intercept first. Now the x-intercept you have to go back to y equals, and we're going to put a 0 in y2 because y equals 0 is technically the x-axis. So I want to find the intersection between my x-axis and my curve or my exponential. So I'm going to put y2 with 0, and then I'm going to press second trace, and I'm going to go down to intersect. So when I press intersect, you're going to notice that the first curve is your exponential, so you're going to press enter. The second curve is that y equals 0. And then it's going to guess, and you press enter one more time. So that intersection is going to be your x-intercept. That is at 4.756. So that's our x-intercept. The other way that you can do this is you can go to second trace, and you can click on 0. And then right where you have to sort of approximate where your x-intercept is, you can go a little bit left bound and go to the left of that x-intercept, or go to the right. So a little bit above your x-intercept, press enter, and then enter again. It will give you the same answer, or the same 0, same x-intercept. Now, in order to find your y-intercept, we're going to go to our table. So second graph, and when my x is 0, that's going to be my y-intercept. So what we have, because we had that vertical shift down, our asymptote is at y equals -5. So we're going to go here. Okay. Our x-intercept was about 4.756. So right now we're just doing a sketch here. Our y-intercept was -4.936, so like about here. And then you can give our curve here for exponential. Domain is going to be all real numbers, or -infinity to +infinity. And our range, of course, based off of our shift that our asymptote went down. So we're going from smallest y, which was -5, going all the way up towards +infinity. Our graph is increasing, right? Our graph is increasing. So from left to right, we are going up. So we are increasing on the interval of -infinity to +infinity. And then again, as we look at end behavior, we're looking to see what's going on. So as x is approaching -infinity, I'm looking at the left side of my graph. So that value that your graph approaches is -5. And as x approaches +infinity, I'm looking at the right-hand side of my graph, and my function is going to approach +infinity. Thanks for learning with me today, unlocking the power of math, one problem at a time. Don't forget to like and subscribe for notifications on future pre-calc videos. See you in the next lesson.